Your browser is basically a tiny operating system pretending to be a window, and inside that window, your web page is a living creature made of nodes. There are two big maps JavaScript uses all the time, the DOM and the BOM. They sound fancy, but once you see the difference, it's actually pretty chill. And for the security, especially DOM-XSS, this stuff matters a lot. Hi everyone, I'm Admiral Crab and welcome to the channel. Here we break down cybersecurity topics in a simple, practical way, especially bounty hunting and penetration testing. So please do like and subscribe to the channel if you're interested in those topics. Let's get into it. Let's start with the DOM and document object model. When your browser loads an HTML page, it doesn't just keep it as text. It builds a living tree of objects in memory elements, text, attributes. Everything becomes a node. So the DOM is basically the web page as JavaScript can touch it. If there's a paragraph like this, a p tag with MSG ID and a hello inside of it, JavaScript can calmly walk up to it and change it like this one. No reload, no drama. The page updates instantly. Changing what the user sees, reacting to clicks, updating text, adding elements, removing stuff. It's basically classic interactive web behavior. Now the BOM, the browser object model. BOM isn't about the page content. It's about the browser environment around the page. The tab, the URL, navigation history, storage, dialogues, timers, all the tools the browser gives you. So this is the easiest way to think about it. DOM equals to document or the page, and BOM equals to window or the browser world around the page. So things like these are BOMish: window.location, window.history, alert, confirm, or prompt, local storage, set timeout. It's like the DOM is the room you're in and the BOM is the whole building. Here's the neat part. In the browser, the DOM lives inside the BOM because document is available as window.document. So when you hear window is the top level object, that's what people mean. You're in the window universe, and inside it, you've got document, and inside that, the full DOM tree. Security angle, where DOM-XSS comes from. Now let's talk about why security folks care about them. DOM-based XSS happens when the page's JavaScript takes untrusted data from somewhere and inserts it into the page in a way that makes the browser treat it like HTML or code. A clean mental model is source to sink. Source is where attacker controlled data comes from, and the sink is where that data gets executed or rendered dangerously. Common sources. A lot of sources are from the browser itself, meaning BOM-style data. Location.href, location.search, location.hash, document.referrer, window.name, or local storage. These are all things an attacker can influence by sending a crafted link, open a page in a certain way, or controlling navigation. Common sinks. Sinks are the places where strings can become HTML or code, like inner HTML, document.write, eval, new functions, or set timeout. If attacker input reaches one of these without proper handling, it's game time. Simple DOM-XSS example. Imagine a page does this. If an attacker sends someone a link like this one, then the script pulls name from the URL and writes it directly into the page as HTML, and the browser happily runs it. That's DOM-XSS. The server might not even reflect anything. The page attacks itself because of its own JavaScript logic. A sneakier one, window.name. One more cozy little trick attackers love is window.name. Some apps read window.name and dump it into the page like welcome.innerHTML equals window.name. But window.name can be set when a window is opened. There is a window.open that gets two strings. First one is the URL which the user will navigate to, and the second is the attacker's payload. Now the victim page takes the value and injects it into inner HTML, and done, alert is popped. People sometimes call this DOM-based XSS because the source is a BOM property, but in practice, it's still the same idea, just an input into the dangerous sink. How to defend? The calm, effective approach is 1. Treat browser-provided data as untrusted, like URL, hash, referrer, window.name, or storage. And 2. Avoid dangerous sinks unless you absolutely must. The simplest upgrade is switching to safe output like text content. Now a script tag is displayed as text, not executed. Other good layers are also use a real sanitizer if must render HTML, use CSV to reduce damage if something slips through, use trusted types when available to block risky DOM injections by default, and please don't use eval on anything you didn't generate yourself. So the takeaways: DOM is the page content tree or document, and BOM is the browser environment toolbox window. DOM-XSS happens when attacker-controlled data flows from a source into a dangerous sink, and a lot of sources live in the BOM, URL parts, referrer, window.name, storage, you name it. Once you start thinking in source to sink, you'll catch DOM-XSS patterns way faster. So that's it. Thanks for watching the video and have a good time.